Hey everyone, and welcome. Today we're pulling back the curtain on the super high stakes world of railway engineering. We're going to talk about a process that is absolutely essential for keeping trains safe and running on time, the fleet check. It's this massive, invisible effort that keeps the whole system moving, so let's just dive right in.
So let me ask you this. How would you find one single tiny crack on a train? Now, what if you had to find that same potential crack across an entire fleet of hundreds of trains, each one traveling thousands upon thousands of miles? That is the massive puzzle that engineers face, and it's exactly the problem a fleet check is built to solve.
You know, the best way to think about this is like a health screening, but instead of for one person, it's for an entire family of trains all at once. And it's not just a routine checkup either. It's a targeted, super systematic investigation designed to hunt down one specific problem before it gets a chance to become a real problem. Okay, so let's get into the nuts and bolts. What exactly is a fleet check? And what kicks one off in the first place? As you're about to see, it is way, way more than just a quick look over. Right, here's the official definition. And a couple of words here are really, really important. Coordinated and time-bound. That tells you this is no random bit of troubleshooting. A fleet check is a full-on campaign, a planned, strategic mission to tackle a potential threat across an entire class of trains.
So what actually triggers one of these campaigns? Well, it could be a whole bunch of things. Maybe you see a sudden spike in a certain kind of technical failure, or a new fleet of trains is coming into service and needs some extra eyes on it. It could even be a safety alert straight from the manufacturer. Or sometimes it's the data itself, subtle trends picked up by monitoring systems that whisper, hey, something's not quite right here.
And when we talk about scope, just look at this. It's huge. A fleet check is incredibly thorough. We're not just looking at one thing. Engineers are digging into everything, from the huge heavy-duty parts like bogies and suspension, checking for cracks and wear, to the brakes, the doors, the couplers, all the way to the code, the onboard software, looking at fault logs and making sure all the firmware is up to date. It is a complete top-to-bottom teardown. Okay, to really bring this to life, let's zoom in on a classic case study. We're going to focus on one of the toughest and most critical challenges in the entire industry, hunting for hidden fatigue cracks. This is serious stuff. Why is it such a big deal? Well, according to UK national incident reports, about 12 incidents every single year are linked directly back to fatigue cracking. Now, 12 might not sound like a huge number, but in an industry where safety is absolutely everything, even one incident is too many. That number makes fatigue a top priority. So what happens the moment a crack is found? The response is instant, and it's methodical. First, detection. Bam! Right away, an immediate fleet-wide check is launched on every similar train to see just how widespread this thing is. Then comes the assessment and the really deep analysis, where engineers have to figure out, are these cracks just surface level, or could they grow and cause a catastrophic failure down the line? And this quote right here, this is brilliant. It really gets to the heart of the engineering challenge. It's not always as simple as find a crack, stop the train. They use the train with the worst damage as their absolute baseline. From there, they do some incredibly complex calculations to see if other trains with smaller cracks can actually keep running safely, maybe with more checks, while they work on a permanent fix. It's this amazing balance of ensuring safety while keeping the railway moving. Now, you can probably imagine doing all of this analysis with a pen and a clipboard would be a total nightmare, right? And that's exactly why technology has completely revolutionized the fleet check. We've literally gone from clipboards to the cloud. The difference is just night and day. What used to be these slow physical inspections with mountains of paper records is now a world of remote monitoring and instant, centralized data. The biggest game changer? Instant sharing. An inspector can log an issue in a depot, and an engineer hundreds of miles away sees it that second. It completely flips the script from just reacting to problems to actually predicting them. In these modern digital platforms, they're not just fancy spreadsheets. They're the whole shebang. They let inspectors log findings with photos as evidence. They manage functional tests. They can even pull in live data from sensors on the train itself. You end up with this complete, living digital history for every single vehicle, which makes it possible to track everything, monitor fixes, and guarantee every train is meeting the absolute highest safety standards. So it's really easy to just think of all this as super advanced maintenance. But honestly, that's missing the big picture. When you do it right, a fleet check program has a massive strategic impact on the whole business. So why does this all matter so much strategically? Well, think about it. By catching these problems early, you extend the life of these trains, which are incredibly expensive assets. You slash unplanned downtime, which means fewer delays and happier passengers. The data you collect helps you make smarter decisions about what trains to buy next. And maybe most importantly, it all builds confidence. Confidence from the safety regulators and confidence from every single person who steps on that train.
So to wrap this all up, here's a thought to leave you with. We've gone from clipboards to the cloud, from fixing broken things to predicting when they might break. With AI and sensors getting smarter literally every day, what's next? Are we heading toward a future where a train could detect its own potential flaw, talk to the rest of the fleet, and trigger its very own check, all without a human lifting a finger? It's a pretty wild thought, and it shows just how far this tech could really go.